Hello friends, this video on application of integrals part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. Let's take a new topic called area between two curves. Here we have two curves defined and we have to find the area between two curves. So in this case, if my fx is this function, gx is this curve, the area will be, if you see, fx minus gx dx, and we have to integrate from a to b, for example, in this case. Why I am finding this, how I am found this area is, if you see, if you find the value of fx dx dx, will be this whole area, this guy, if you see, right, this guy, this whole thing, and gx dx will be nothing but the one in the white area. Gx dx, if you integrate, the one in the white area. So if you subtract this whole thing from this white one, right, what you get is the area between two curves, and that's how you got this equation. So there is nothing new concept in this. This is a logical thing. Actually, you understand the figure, and by understanding the figure itself, you can draw or you can get this derivation. The area will be nothing but you take this big area, and from this you subtract the small area, this guy, you get this area. Correct? So let's take one more example where we have this kind of equation, where we have this kind of thing. So here what we do, we find this area separately, and then we add. So here also, if you see fx gx, right, here I am taking gx fx. Why? Because this guy is gx and this guy. So you don't worry about all this thing. What you can do is, you can just, in your exam, what you can do is, you can divide into small pockets, and you take mod of this. If you take mod of this, you take mod of this area, because area is always positive. You don't worry about the signs also. But here logically, if you see what they have done is, because in this case, this area is nothing but gx minus fx dx. Why? Because gx will take this big area and fx will take small area. You subtract this. In this case, if you see, the fx is turning here, right? This guy is fx. So fx is this guy, if you see. Correct? So fx is turning. So in this case, the area will be fx gx, and here will be gx minus fx minus gx here. So here also I'll advise the same thing. Don't go much by formula. Observe the question, understand the question, and then solve it. Just solve it by your intuition. We'll take some example. We have to find the area between the circle and which is interior to this parabola. So I have this parabola and I have this circle. I have to find the common area between this circle and this parabola. So that means what I'm talking about is, this area. If you see, the area in blue is the common area, this guy and this guy. So I'm talking about this area. This is the only common area between these two curves. So what I can see is area of this is nothing but twice of area of this, because these two areas are symmetrical. Let me put the values here. This, let's suppose, is 0 O, this is P Q R. This point, let's suppose, will have A, this point will have B, this point will have C, and this point will have D, let's suppose. So if you see, we have to find this area. The area of OR CQDO, this area, and this area of ORBPA, they are same. So I can say that my area is nothing but required area twice of area of OAPBR. OAPBR. So you can find this, or O here also, OAPBR, twice of this area. And I always try to take the area in first quadrant because they are x and y both are positive, so with that the calculation is simple. So that's one reason why I always take the x quadrant. So this I take and I find twice, I get the area. Now finding this area is little tricky, because here this is the curve between area between two curves. So finding this area is not that tricky. If you draw this line here and call this point, let's suppose, T. If you know the value of T now, finding this area is simple now. Because finding this area is nothing but you find this area, complete area, subtract this area, you get this area. I'll show you. Area of this is nothing but 2 into area of, I'll find this complete area OTPBRO. OTPBRO minus area of this guy OTPAO. OTPAO. So what I'm doing here, if you see, I'm finding the area complete, the whole area OTPBRO, this area, because this area finding is simple. This area is nothing but you integrate this curve with respect to x-axis from 0 to t, and then I'm saying 0 to PAO. Finding this is also simple. You integrate this curve here this time from 0 to t, get the area. Correct? And we'll do that. But before we do that, we should know what is the value of t, because we are integrating from 0 to t. So if you see now here, let's do this. Area of OTPBRO is nothing but y dot dx from 0 to t. T is something which we'll find. I'll tell you what the value of t is, minus here also y dot dx 0 to t, and this is y1, y2. Let's suppose, because this curve is, let's suppose, y1 curve, and this curve is, let's suppose, y2 curve. So in this curve, y1 dot dx, if you say, so if I take this curve, my y will be nothing but, if y will be nothing but 4y square is nothing but 9 by 4 minus x square, and y is root of this, right? So what you get is this guy, here is 4, once again. So if you see 4y square is equal to this, so I'll tell y will come out to be 9 minus 4x square by 4. So this becomes root of 9 minus 4x square by 4, the whole thing under root dot tx, and you integrate from 0 to t, minus this guy curve y2, y here will be x square by 4. So this becomes x square by 4 dx from 0 to t. Now the only challenge I have here is, I know how to find everything, I know. The only challenge is to find the value of t. How to find the value of t? So to find the value of t, we define the point of intersection q and p, because q and p, the x coordinates is same as what you have in t, and this point also, we are not interested in that. So this point, if you can find p, I can find t x coordinate also. Y anyway is 0, so I can find t also if I find t. To find p, I have to find the common point of intersection between the curve, these two curves. The curves I have is, let's do this. So x square plus y square is equal to 9 by 4, and x square is equal to 4y. Correct? So let's x square is equal to 4y here. So this becomes 4y plus y square is equal to 9 by 4. Now we have, with this I'll solve this. So this becomes, actually equation becomes y square becomes 4y square, and 4 into 4 16y, minus 9 is equal to 0. Factorize this is 36, this is 16, I can write 18 into 2, so, or 18 minus 2 is 16 also. This becomes 4y square plus 18y minus 2y minus 9 is equal to 0, or I get, you solve this, 2y common, this into 2y into 2y plus 9 minus 1 equal to 0. So I can say y is equal to 1 by 2 or minus 9 by 2. Why can't we, since we are talking about these points in this, y is positive, correct? These 2 points I'm talking about here, y is positive, so ignore the negative part here. So I can take y is equal to 1 by 2 and see what is the value of x. If I take y is equal to 1 by 2, my x becomes, if you see, x is nothing but root 2y. So x is nothing but root 2y, that is root 2 into 1 by 2. Sorry, x is root of 4y, that is 2y. So x becomes plus minus, actually x becomes, I'll write here, x is plus minus 2y, that is plus minus 2 into 1 by 2 root y, actually 1 by this one, because 1 by 2 becomes 1 by root 2, correct? Y is 1 by 2, root y is this guy, so this you get plus minus root 2. Since I am talking about this point, I'll say plus 2 only, so this guy is nothing but root 2 comma 1 by 2, and this point t is nothing but root 2 comma 0. So I know x varies from, I know the value of t now, that is root 2 comma 0. I have to just put the value of t in this equation and solve it and get the answer. So let's do the numerical part in the next slide. But by the concept, it is clear. What we have to do, we have to find the area of this guy. This guy is nothing but the area of twice area of this guy, right? And area of this guy is nothing but area of this guy minus area of this guy. We found the area of this guy by integrating this equation with respect to x from 0 to t, and we found the area of this guy by integrating this equation with respect to from 0 to t. We didn't know the value of t, we found the value of t to be root 2 comma 0. Now we'll do the calculation part in the next slide. So let's do the calculation part here. From the last slide we found that required area is nothing but 2 into integration of 9 minus 4x square dx, root of this whole thing, by 4, and x varying from 0 to 2, 2 is root 2, minus again 0 to root 2, x square by 4 dx, correct? So let's find the value of this. So this becomes, if you see, 2 into, your root 1 by 4 is 1 by 2, and root 9 minus x square, if you integrate, so this becomes x root 9 minus 4x square plus 9 by 2 sine inverse 2x by 3, because this is 2x square, this is 3 square, right? 3 square is 9, 2x square is 4x square, from 0 to root 2 minus this guy will become 1 by 4 x cube by 3 from 0 to again root 2, and the whole thing is multiplied by 2, correct? This is nothing but 2 into, this becomes 1 by 2 now let's put the value here. X becomes root 2, so this becomes root 2 into 9 minus 4 into x square is 4 into 8 plus 9 by 2 sine inverse x is 2 into root 2 by 3 minus 1 by 4, x cube becomes root 2 cube, that is 2 root 2 by 3, correct? So if you solve this, there will be one more 1 by 2 component here. So actually the way you get 1 by 2 here is because 1 by 2 is multiplied, so that's you get. So if you solve this, this guy is nothing but 2 into, this becomes root 2 by 4 plus 9 by 2 into 2 into 2, 9 by 8 sine inverse 2 into 2 by 3 minus, this becomes root 2 by 6, right? This whole thing into 2. So if you solve this further, this is nothing but root 2 by 6 minus root 2 by 4 minus root 2 by 6, that is root 2 by 4 minus root 2 by 6. If you take 12 common, this becomes 3 root 2 minus 2 is root 2 plus 9 by 8 sine inverse root 2 by 9. You multiply with 2, what you get is root 2 by 6 plus 9 by 4 sine inverse 2 root 2 by 9, and that is my answer, correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.